with you related to collision. Have you find out? Please look into your WhatsApp group. Questions related to collision. Hello. Hello.
Yes, sir.
Have you find? Okay, beta. So go through question number 1. So now I'm going to discuss questions related to collision. ठीक है? So collision. Okay. Question number
So
1.
the last two questions of the previous,
Okay. Last question of the previous. Just 1 second. I'm going to discuss.
the last two questions were left
Yes,
over.
yes, beta. Just 1 second. I will discuss those questions where, okay, I find out. Two questions were left there. ठीक है, last and second last. ठीक है. One question was, second last question was, you can find out a shell is fired from a cannon with a velocity v at an angle theta with the horizontal direction. At the highest point in its path, it explodes into two pieces of equal mass. If one of the pieces retraces its path to the cannon, ठीक है, then calculate the speed of the other piece immediately after the explosion. ठीक है, you have to find out. If one of the piece is retracing its path and then calculate the speed of the other piece immediately after the
पीडीएफ
collision.
सेंड कर दिया ऐसे
Okay, ठीक है. So this question was there in the last PDF I have shared in the morning. ठीक है. Whatever PDF I have shared in the morning, this question is there. So here it is like this. You are having, suppose, a block here, okay, and you have launched this at some angle. With some velocity, you launch this. It is moving like this on this path. And at the highest point here, it is exploded into two parts. So you are launching this at a velocity, suppose u velocity, and this will be theta. Okay, this will be theta. So here, suppose its mass is 2m. So what will be mass here? That will be 2m. And at the highest point, its velocity will be how much? Its velocity should be u cos theta. So this should be u cos theta at the highest point. Now what they are saying that at the highest point, it is it it splits into two parts. One part is this. If this is h, then I'm showing you this is h. They are saying that one of the part is going to retrace its path. So what they are saying, suppose this is going to retrace its path like this. So automatically when it is going to retrace its path, if its velocity is exactly in the opposite direction, so what will be its velocity? Its velocity here, when it is going to retrace its path, if this velocity, this will be u cos theta, but in opposite direction. ठीक है, only then it is going to retrace its path. So this is going to follow this path. ठीक है ना? And I don't know, it will have some velocity because it was just horizontal velocity. So total momentum will remain conserved. Initial momentum here before the collision, that was 2m mass into what was its velocity in the x direction. This was u cos theta. This will be equal to this one. So it is having mass m, this is going to have mass m. So this is having velocity in the opposite direction. So this will be m, mass m. After explosion, this will be minus u cos theta. And I want to find out the velocity of this. Automatically, it will be in the horizontal direction. This will be v. So I will write it plus mv. Okay? Plus mv, I want to find out this. Is this equation clear to everyone? So what will be v? You have to find out. This is 2 here, so this will be 3. So this will be 3 mu cos theta. This is also a very good question for the exam. This will be m into v. So m is going to cancel out, and this v will be simply 3u cos theta. This will be 3u cos theta. This will be your answer. Okay, so here, if this particle is launched of mass 2m, it is launched at an angle theta with a speed u. Then at the highest point, okay, this mass is going to have only horizontal component of velocity, and this will be u cos theta. So at this point, its momentum will be 2m u cos theta. U cos theta. Now it exploded into two parts. One part is this, another part is this. ठीक है, one of the part is going to retrace its path. So when it is going to retrace its path, if its velocity is same, so whatever velocity was here, same but in opposite direction, it should have velocity only, then it is going to retrace its path. ठीक है, so this will be u cos theta. It will be u cos theta beta. In that case, exactly opposite, in the opposite direction, it is going to retrace its path. Second part, it is, I'm assuming its velocity is in v in this direction. Why? Because initial momentum was horizontal in this direction. A part of momentum that is in horizontal direction but in opposite direction. So automatically its momentum should be in this direction too, due to the conservation of linear momentum. I created this equation and find out this v in this way. Is it clear?
Yes, sir.
Now go to the last question. ठीक है? Go to the last question. I think this was 11, number 11 question. ठीक है? And this was a part of work, energy and power. ठीक है? Work and energy particularly. And last question, question number 12 of that sheet is question 12. A body of mass m is dragged with a uniform velocity 2 meter per second on a rough horizontal plane. So this is a rough horizontal plane, and a body is dragged with 2 meter per second. ठीक है? 2 meter per second here on a rough horizontal plane. The coefficient of friction between the body and the surface is 0.20. So they are saying that mu here, this is a rough surface and this is 0.20. 0.20. ठीक है? This is, now the J is equal to 4.2 joule per Kelvin. That is okay. And G, calculate the amount of heat generated in 5 seconds. So how much heat will be generated here? So if you want, try to understand, if you want to maintain this constant velocity 2 meter per second, then because it is moving on the rough surface, so automatically a friction force is acting in the opposite direction. ठीक है? And if you want to maintain this constant velocity, you want that this block should be dragged with 2 meter per second for how much time? For 5 seconds. Then you have to do work against this friction force. Then you are going to do the work against this friction force. ठीक है? So how much, can you tell me how much it will be displaced? This block will be displaced in 5 seconds. Suppose this block will be here. after 5 seconds. So I'm saying t equal to 0 here, and this block will be here in 5 seconds. So how much displacement will be there? Displacement in the horizontal direction, that will be 2 meter per second into time. Time is 5 seconds. So this will be 10 meter. Okay. So displacement in 5 seconds will be equal to 10 meter. Now second, work is done against the friction force. So how much work will be done against the friction force? So that will be F into S. And how much this friction force will be? This will be mu K into N. Its mass mg, its weight mg is working in the downward direction, and this will be the normal reaction. So N will be equal to mg. So I can write here mu N. This will be mu N into S. Now mu mg into S. This will be the work done and this work done, because you are doing work against the friction force. So automatically when this block is moving, due to the friction, some heat energy will be emitted. This is try to understand. This is a dissipative force. So this friction force is a dissipative force. What I am saying here, friction force is there. Friction force is dissipative. This is a dissipative force. So continuously your system is losing energy. Okay? System is losing energy. You can say block is losing energy in the form of heat. So block is losing energy in the form of heat. In the form of heat. So automatically velocity of this block should be reduced. What will happen if it is losing energy? Then automatically its kinetic energy it is losing kinetic energy in the form of heat. So its speed should move down. ठीक है ना? Its speed should reduced. But for that purpose you are doing the work. ठीक है? For that purpose you are doing the work so that its constant speed can be maintained. So whatever work you are doing, exactly same amount of heat energy system is losing per second. ठीक है? In this duration so in this duration, whatever work you have done, same amount of heat energy is lost by the system. So whatever W you are calculating, that will be actually equal to the heat generated. So this will be heat generated actually. That is point 2. And mass, substitute all these values. What is the mass of the block? That is 2. And this will be, G will be 9.8 multiplied by S as you have calculated 10. ठीक है? This will be 10. So if you want to write G equal to 10, then you can also use this. But if you are doing this, this will be 39.2 joule. 39.2 joule. ठीक है? This is 2 to the 4, 10, 40. So it will be a little bit less than joule. ठीक है? And 1 calorie is equal to 4.2 joule. ठीक है? You know this conversion factor. So if I divide this by 4.2, then your answer will be in calorie. So this much amount of heat energy will be lost by the system. This comes out to be 9.33. This will be how much? This will be 9.33 calorie. This much amount of heat energy will be lost by this system. So this was the last question I have shared in the morning. Now come back to the seat of collision. So next is, please note it down quickly. Then I will go to the next sheet. Collision. Question number 1, beta. A gun fires a bullet with speed VR relative to the barrel of the gun, which is inclined at an angle of 60 degree with the horizontal. So there is a gun like this. Try to understand. This type of gun is there. ठीक है, with barrel, and bullet is somewhere here. ठीक है ना, this is the bullet. Try to understand. Right now, what is the momentum of this system with respect to Earth? So I will do calculation with respect to Earth. And this angle, it is given as 60 degree. Now you are going to tell me what is the initial momentum. So Pi, initial linear momentum is 0. 0. ठीक है? Next is, when this will fire, this bullet will be fired by this system. Here, it will move like this. ठीक है ना? It is going to move like this. This is VR. But this VR is the velocity of the bullet with respect to this gun. You can say this is gun, this is bullet, and this is earth. It will be something like this. Okay. So what will be the horizontal component of this? Try to understand what will be the horizontal component of this. Horizontal component of this bullet will be, you can say here, this will be VR cos 60 degree or VR upon 2. So I'm writing velocity of this bullet, velocity of the bullet with respect to gun, that is x component. I'm just taking x component. This will be VR upon 2. This will be VR upon 2. This will be. ठीक है ना? So ये कितना होगा बेटा? That will be VR upon 2. Now, velocity of the bullet with respect to Earth you want to find out. What is your objective? You want to find out velocity of the bullet with respect to Earth. Now, when bullet will be fired, can you tell me in which direction this gun is going to move? After the firing of bullet, this gun will recoil in this direction. So basically this gun will recoil in this direction, and I'm saying this is V. V. So what I'm writing, this is velocity of the gun with respect to Earth, and that is minus V. And you want to find out V recoil speed. This is recoiling speed of the gun. This is recoiling speed of the gun. Of the gun with respect to Earth. So what will, because I want to do all the calculation, I want to find out PF with final linear momentum with respect to Earth. So the momentum of the gun with respect to the Earth will be simple minus, this will have minus, ठीक है ना, mass of this will be m, and this will be v, ठीक है ना, this will be, तो suppose mass of this is capital M, ठीक है, mass of this is capital M, I'm saying this now. Okay, so what will be the velocity of the bullet with respect to Earth? I have told you this type of formula. So bullet is there, earth is there. What is third body missing? Third body is missing. Bullet is there, earth is there. So third missing body is gun. So what you are going to write, you will write velocity of the bullet with respect to gun minus velocity of the earth with respect to gun. So this will be VBG. VBG is VR upon 2. VR upon 2. And this is GE. So if VG is minus V, then what will be VEG? That will be simply V. Simply V. This will be. So this is the velocity of the bullet with respect to Earth. ठीक है, so total momentum will be momentum of this gun with respect to earth is minus mv and momentum of this bullet, ठीक है, with respect to earth in horizontal direction that will be positive. Mass of the bullet I am saying it is of mass m here, m, and its velocity will be vr upon 2 minus v, and this will be equal to how much both are equal. So it will be equal to 0 because pi will be equal to pf. Pi, this will be exactly equal to pf. So this v will be how much? This v will be equal to, this will be m vr upon 2 minus v upon capital M. Upon capital M, beta. Is it okay? But here, sorry. This is V okay, but this V is also there. I forget this. So please add up both these. So this will be, take this MV and this MV on the other side. So you can write like this M plus M, and that is V. This will be MVR by 2. So what will be V here? V will be MVR upon 2, and this will be M plus M. It should be something like this. This type of answer should be there for the recoiling speed of the gun. This is a very, very good question. Beta. Try to understand. In this question, they have used basically concept of relative velocity as well as ठीक है, linear momentum, and you have to understand whenever you are applying the conservation of linear momentum, your frame of reference should be same. So here you are finding the linear momentum of this gun with respect to earth and the linear momentum of this bullet with respect to earth. Okay? So they should, all the calculations should be in the same frame. So here we are choosing earth as a frame in which I am doing the calculation. This is a very, very good question. Is this question clear to everyone?
Yes, sir.
Good. So this was question number 1. Now go through question number 2. Please go through question number 2. This was question number 1 of your sheet. Question number 2. A particle of mass 2 kg is initially at rest. Okay, so mass of the particle is 2 kg. Just one. 2 kg. Its initial velocity u is 0. So it is moving from the rest. A force starts acting on it in direction whose magnitude changes with time. The force time graph is shown in the figure. Find the velocity of the particle at the end of 10 seconds. So this type of plot is given to you. On the vertical axis, you are having force, and here you are having time. Time. So it's going up to like this. This is 10 here. Then it will go up to 4. This is 4. Here this was 2. and then it will move up to 20. So 20 is here, somewhere here, and this will be 6 here. So it's moving like this, and then 6, then this is 8 here, and this is 10 beta. In this way. Okay? So this arrow should not be there. Please don't write this arrow. So can you tell me what this area covered by this curve is going to provide you? Area of this curve enclosed between this horizontal time axis and this curve, what that quantity will be? Bolo? What will be that quantity? How you write this enclosed area? This enclosed area will be written as the quantity on the y-axis and quantity small interval. So this is time, so a small time interval here. And if I integrate this, that will be the area. Area enclosed is actually this one. And what is this? You know that force. Okay? You are well aware that what is force? Force is here. Force is dp by dt. dp by dt. So what this quantity is going to give you, this area, that will give you change in momentum. So this will be f dt. ठीक है, f dt, and this is enclosed area. This is enclosed area. So this is change in momentum. And change in momentum or this quantity, you also call it as impulse. But in general here, this time is quite large, so I should not write impulse here. ठीक है, for impulse, force is applied for a very, very small interval of time. So if we are choosing 10 second with a very small, ठीक है, small time, then you can consider it as impulse. Otherwise, this is change in momentum. Okay, so this quantity calculated initial, so this will be PF. Change in momentum will be PF minus PI. PI was 0. This was 0 because body was starting from the rest. Find out this area. So this will be 1 by 2 into 2 into 10. So first will be 1 by 2 into 2 into 10. First triangle. This will be 2 into 10. This will be 20. This will be our trapezoid 4 plus, this will be 10 plus, this is 20. ठीक है ना? 10 plus 20 by 2 into 2. So this will be plus 1 by 2, 2. ठीक है? And this will be 10 plus one side is 10, another is 20, and multiplied by separation between these two parallel line is this. And this last one is a triangle. So this will be 4 into 20 plus half into half. So this will be 4 into 20. So this will be 10. PF will be how much? This will be 10 plus 20 plus 30 plus 40. Think, so this will be 100. ठीक है, kilogram meter per second. This will be PF. So this will be the final momentum, 100. And if you want to find out, if they ask final momentum, then this will be 100. If they ask you what is the final velocity, then this will be 100 divided by mass. ठीक है, mass is 2 kg, so divided by 2. So this will be 50 meter per second. So your answer will be 50 meter per second. So this was question number 2 beta. ठीक है ना? This is question number 2. Now question number 3. Go through question number 3. Is this clear to everyone?
Yes, sir.
Good. Now go through question number 3. First go through it. Two identical blocks, each of mass 9 kg, are placed on a rough horizontal surface of friction coefficient mu equal to 0.1. So it is like this. This is question number 3. This is a rough surface. One of the block is placed here, another block is here, and they are attached with a spring. A bullet is coming from this side. Okay, so this diagram is given. Mass is m, this is v naught. Okay, its mass is capital M, that is given. So capital M is 9 kg. So capital M here is 9 kg, that is given. Okay, mu is 0.1. So mu is 0.1, that is given. The two blocks are joined by a light spring and block B is in contact with the vertical fixed wall as shown in the figure. A bullet of mass m equal to 1 kg. Mass of the bullet is simply 1 kg as shown in the figure. And V naught kitna hai? V naught here with which this bullet is moving, that is 10 meter per second. So all these numbers are given. Hits block A and gets embedded in it. So what will happen? This is going, initially it is at rest. Now what will happen? This bullet will be here. It will be embedded here. Bullet is now here. So what will be the mass of this? ठीक है ना? Mass of this will become 10. So this will be m plus m. M plus m, and this will be 10. Now it is having a kinetic energy. It is attached with this block like this. So here, before this bullet is hitting, what was the initial momentum? Momentum was carried by the bullet. ठीक है? Bullet was carrying the momentum, mv naught. This block was at rest. So this was initial momentum. Now now this bullet is embedded in it. So mass will become 10. So this will be m plus m, 10. And I'm assuming its velocity is v. So I'm saying after this, it is going to have this velocity. So this velocity v will be m into v naught is 10 divided by 10. So this v is, this will be 10 and this will be, what I've done, this is also 10. 9 plus 1, 10. So this will be 1 meter per second. So this is the velocity of this bullet plus this block together. Now what will happen? Now it is carrying, okay, it is carrying kinetic energy. Now this system together, both these together, they are having a kinetic energy. Now due to this kinetic energy and the momentum in the forward direction, they are having momentum as well as energy. So what this system is going to do, it will move to the right. And when it is moving to the right, this spring will be compressed as well as this block. When this block will move, then try to understand, block will move in this direction. Okay? And friction force is going to act in this direction. So what is the initial kinetic energy of this block? So block plus bullet. So conservation of energy. Conservation of energy. So initially they are having kinetic energy 1 by 2. M plus m is 10 and v square is 1 square. So this is the kinetic energy they are going to have. Now, when it will move forward, some of the energy will convert into the potential energy that will be stored in the spring. Suppose maximally this block suppose goes up to this point. And in this case, this bullet will be compressed like this. And this distance, I'm saying, suppose this is x. And here I'm assuming this velocity is going to be 0. So here kinetic energy will be 0. So some of the energy will be stored in the spring. So how much that will be? That will be 1 by 2 kx square plus some of the energy, some of this kinetic energy will be utilized to overcome this friction. This system has to do work against the friction, so some of the energy will be utilized there. So what will be the mass? What will be the weight here? That will be m plus mg. G. So normal reaction will be there here. So what will be the friction force here? F into x. Okay. So what will be the friction force? Friction force will be mu k into n. You can say mu k, and that will be m plus m into g. Mu k is 0.2, mu, 0.1, sorry, 0.1 they are giving. This is 10, m plus m is 10. And what is g here? What is g? G is given 10. They have given g, whatever value they are providing you, please use that value. So this will be 10. So this will be 5 here. Here, what is the value of k that is given? 240 beta. So this is 240. So this will be 120 x square. And this will be 10x. This will be 10x. Divide this by 5. So 5 to the 10. 5 4 the 20x square plus 2x, and that will be minus 1. And that will be equal to 0. Okay, so you have to factorize this. So 6x minus 4x, I think it will work. 24x square plus 6x minus 4x minus 1. That will be 0. So 6x will be there. This will be 4x plus 1 minus 4x plus 1. So this will be 0. So this will be 4x plus 1. Okay. And this will be 6x minus 1 equal to 0. So one of the possibility is x equal to minus 1 by 4. So this is not okay according to our problem. We are assuming x in this direction. So it is not possible for our case. So what will be x? X equal to 1 by 6 meter. But this should be the answer. ठीक है ना? This should be. Find the maximum compression in the spring. So this should be the answer. I should check. Yes, this will be, this is 1 by 6 meter. So this is 1 by 6 meter. This is the answer. Okay. So this is the answer of this question. Question number 3. Question number 3, beta. Next question. Next question, beta. Please note it down quickly.
Done, sir.
Next question, beta. Please go through that. This question is two particles of mass m and 2m. Two particles of mass m and 2m moving in opposite directions collide elastically with the velocity v and 2v. Find their velocities after collision. Find their velocities after collision. Find out. So what will be their velocities after collision. I have given you the formula. ठीक है? If you remember, I have given you the formula बेटा. करिए जरा. So two blocks are there. They are colliding here. One is moving in this direction, another is moving. So what are their masses? So one of the mass, it is having 2m. It is m. And what are their velocities? For m, it is v. And they are moving in the opposite. So I'm saying this is v. And this is 2v. 2v. ठीक है? So I'm assuming this m1 is 2m. u1 is 2v. ठीक है? m2 is m. And u2, because it is in opposite direction, so this will be minus v. ठीक है? Now we have to find out their velocities. So what will be the velocity of the first block for this v1? ठीक है? After collision, what will be the situation you want to find out? This is v1. कितना था? If you remember, m1 minus m2 divided by m1 plus m2. And this is u1 plus 2m2 upon m1 plus m2, and this will be u2. So 2m minus m, this will be m, and 2m plus m, this will be 3m. u1 is 2v. Here, this will be 2m here divided by 3m. So plus 2m upon 3m, and this will be minus v. So how much it will be? This m will cancel out, this will cancel out. So this will be 2 by 3, 2 by 3, and this will be minus 2 by 3. So it will be at rest. So this will be V1. So after this, after collision, what is going to happen? This first one, ठीक है ना? This will be at rest. This will come to the rest. You can check. ठीक है? Please check the calculation. So this will be V1. ठीक है? So V1 is going to be at rest. Next, second, what will happen to the second? This will be V2 you want to find out. So this will be 2m1 divided by m1 plus m2, and this will be u1 plus m2 minus m1 divided by m1 plus m2 into u2. So 2m1 means m1 is 2m, so this will be 4m divided by 3m. And u1 is 2v, 2v, that is okay. Here m2 minus m1, m minus 2m, so this will be, I'm writing here minus m. This will be m minus 2m, so this will be minus m divided by 3m. And this will be minus v. So m will cancel. So this will be 8 by, this will be 8v by 3 minus minus plus. This will be v by 3. So 8 and 9. So 9 by 3, this will be 3v. So second is going to move this one. It is going to move with the velocity 3v. This will be the situation. This will be m1. Sorry. This is m1. m1 of mass 2m. And this is m2 of mass m. So velocities will be after collision, they will be 0 and 3v just. Correct. So these are the answers. So this will be after collision. So this will be the situation after collision. This is before collision. This is before collision. After collision and before collision. This is. So this was another question. Next question, beta. Next question. Can I go to next?
Please, sir.
Hello. Next question, beta. This one. A ball of mass m moving at speed v makes a head-on collision with an identical ball at rest. So here you are having this situation. Two identical balls are there. ठीक है, I'm assuming its mass is m and it is at rest. And this ball is moving, identical ball, mass is m. ठीक है, mass is m and moving with a speed v. This is given to us. V. I'm saying this is m1 and this is m2. ठीक है, so here u1 is v and here u2 is 0. It is. The kinetic energy of the ball after the collision is 3 by 4th of the original. So what you are saying, Kf final kinetic energy is 3 by 4th of initial kinetic energy that is given to us. ठीक है, find the coefficient of restitution. So when they are talking about coefficient of restitution, means they are undergoing inelastic collision. ठीक है, so this is a inelastic collision. So in case of inelastic collision, this will be V1. What will be the velocity after collision? V1, I should write here, this is before collision. And here I am going to just after collision here. ठीक है, this is after collision. And Kf is given 3 by 4 of Ki. ठीक है, so what will be V1? V1 will be M1 minus E times the E is coefficient of restitution M2 divided by M1 plus M2 into U1 plus this will be 1 plus E M2 divided by M1 plus M2 into U2. U2 is 0. ठीक है, try to understand, this will be 0. U2 is 0. So only this will be there. So I can write it how much? This is V1 mass M and M. So M minus EM upon M plus M. So this will be 1 minus E by 2 and this will be V. ठीक है, this will be. Now V2 will be 1 plus E M1 divided by M1 plus M2 U1 plus this will be M2 minus EM1 divided by M1 plus M2 and this is U2. So here this U2 is 0. So here substitute M and M. So this will be 1 plus E by 2 into V. This will be V2. ठीक है, this will be. Now what you have to find out? You have to find out coefficient of restitution. Coefficient of restitution. So what is given? Try to understand what will be the final kinetic energy. This will be 1 by 2. First block V1 is square plus 1 by 2 second mass V2 square. This is the final kinetic energy. This is 3/4 of initial kinetic energy. So try to understand, here you are having a velocity. This is going to have V1, mass is M1 equal to M. And the second is going to have M2 equal to M, and this will be V2. V2, so this will be 3/4, and this will be 1/2 M. Okay, this will be 3/4 of 1/2 M. And how much it will be? Only this is going to have. So initial kinetic energy was simply 1/2 mv square. So what can you do here? This 1/2 can cancel out. This m can cancel out. Cancel out. So v1 is square. Where is v1 is square? This is v1 is square. So this will be 1 minus e square, and this will be v square by 4. ठीक है? Make the square of this. Plus square of this. So this will be plus 1 plus e square v square by 4, and this will be 3 v square by 4. This type of equation. So if you look at this, this v square by 4 is going to cancel out. This will be 1 plus e square minus 2e. This will be 1 plus e square plus 2e, and this will be equal to 3. 3. Okay, so this 2e is going to cancel out, and this will be 2 plus 2e square, and this will be equal to 3. So e square will be 1/2. So what will be e? E will be 1 by root. So coefficient of restitution, that will be 1 by root 2 beta. So this will be the coefficient of restitution. So here, this is the answer of this question. This was a question there. Next. Next question beta. Please note it down. Sorry. Next one. This is which was this one? This was question number 5. And next will be 6. Please go through this question. After perfectly elastic collision between two identical balls moving with same speed in different directions, okay, the speed of the particle becomes half the initial speed. Find the angle between the two before collision. So I am saying, suppose one of the particle that was moving like this, its velocity was here. So just 1 second. So I'm saying this was suppose it was moving like this. Its velocity was v and mass is m. Second is here. Same, identical. They are hitting like this. And this is v. They are like this. Suppose angle between them is, I say this is 2 theta. I say this angle is 2 theta. Can you tell me what will be the direction in which they are going to move? Now they are clubbed together. So in case of perfectly inelastic collision, this is perfectly inelastic collision. Perfectly inelastic. Elastic collision. So इसमें क्या होगा? They will stick together. They will, colliding balls will stick together. together and move. In which direction they are going to move? So here in collision, momentum will be conserved. So try to understand, this is the momentum. This is going to have a momentum mv. This is going to have a momentum mv in this direction. So component of this momentum in this direction will be cancelled out. If you consider this vertical direction like this, then momentum here, this will be mv, mv sine theta, this will be, and here this will be mv sine theta like this. This will be mv sine theta. ठीक है, so they are going to cancel out. Both these, they are going to cancel out each other. What will happen? They are going to have a momentum in this direction. The resultant momentum will be here 2mv cos theta. If this is theta, this is theta. So now both the blocks, this block and this block, okay, so they are going to move with velocity v. I'm saying they are moving with a velocity v. So what is the initial momentum in this direction? That will be 2mv cos theta, and final momentum, total mass will be 2m, and it will move with a velocity v. ठीक है ना, it will move like this. Is it okay or something else? बोलिए बेटा. And how much this v is given? This is given as u by 2. So or v by 2, sorry. You can write it in half of the initial velocity. This is given, so okay. I can write 2mv cos theta. So this will be 2m v by 2. So 2m is going to cancel out. V is going to cancel out. Cos theta is 1 by 2. So theta is 60 degree. So what will be 2 theta? Angle between these two. So 2 theta answer will be 120 degree. So initially they were moving at 120-degree angle with each other. So this is the angle. Okay, initially they were moving with. Is it clear up to this point? Hello.
Yes, sir.
Good. बेटा तो नेक्स्ट क्वेश्चन आप ट्राई करना थोड़ा. आई विल ट्राई टू हैव ए क्लास after 2 days. I will try to take a class. ठीक है, and I will complete not only this, but I will start discussing. In next class, I will explain you whatever questions are left. Please try to solve these questions, and then I will start center of mass. ठीक है ना? Moment of inertia I have already done. ठीक है, I have already discussed moment of inertia in detail. Moment of inertia, tensor, everything I have already discussed. So this part I am going to discuss center of mass, angular momentum, torque I will discuss. ठीक है ना, torque and angular momentum. First I am going to discuss this, and then rotational motion. ठीक है, these three. First I am going to discuss these three. So this is the starting, this will be the starting of rotational dynamics from here. So from the next class, I will discuss rotational dynamics. So first I will explain these three concepts, and then different type of rotational motions. ठीक है ना? So फिर rotational motion here. Rotational motion. In this way I am going to move.
हेलो सर.
हाँ जी बेटा बोलिए प्लीज.
सर और कितने क्लास कवर करने में लगेंगे सर इसको?
I think one in 2 classes I will complete it. ठीक है, roughly 2 classes I will take this 2 class and 2 class here. So in next 4 classes I will complete it. So by the end
सर
of
फ्लूइड
by the
मैकेनिक्स का अलग क्लास होगा?
किसके लिए? fluid mechanics will be after this. ठीक है, I will take for fluid mechanics 2 classes or 3 classes. 3 classes for fluid dynamics. ठीक है, 2 parts of this are there: fluid statics, fluid dynamics, and third part you can say surface tension. So fluids, actually this consists of 3 parts: fluid dynamics, fluid statics, fluid dynamics, and surface tension. ठीक है, so this will be,
सर
yes beta please.
कोरियोलिस फोर्स वो पार्ट हो चुका है क्या?
Beta I have already done that part. ठीक है, when I was discussing rigid body dynamics, you can look into the video lectures. ठीक है, I have already covered that part with numericals.
ओके ओके
ठीक है, so only this is left in your syllabus. So 4 3 7. ठीक है, roughly 7 or 8 classes I will further take to complete your syllabus.
सर
Yes
इसमें
बेटा.
सर एक्स्ट्रा क्लासेस के साथ ये सब हो सकता है क्या सर? लाइक
हाँ बेटा. When is your
कर
what is
रहे
the
हो
date of your exam?
सर 15?
Okay, so I will try to complete it. ठीक है ना? I will try to complete it by Monday or Tuesday. ठीक है, so I will try to take extra classes on Sunday. ठीक है, morning and evening. So in morning and evening I can take 2 classes, one more class in between, so 3 classes, and then on Monday, Tuesday. So more or less, at least your rotational dynamics will be completed by Tuesday, Monday or Tuesday. ठीक है,
ये सर क्योंकि
then
इस वीक में सर ओनली 2 क्लासेस बस शेड्यूल में ऐसा अपडेट हुआ
कोई
है।
बात नहीं, इट्स ओके, आई विल चेंज दैट शेड्यूल.
ओके सर।
ठीक है, ओके बेटा.
थैंक यू सर।
थैंक
वेलकम
यू
बेटा.
सर।
वेलकम बेटा, गुड नाइट बेटा.